Hi students, welcome to Max Point of View. Today we are going to understand the concept of calorimetry, that too part A. So in part A we are going to learn each and everything. After learning and understanding, not only learning, it is mainly based on understanding the concept. Once we understand it, we'll solve each and every theory question. After that we'll solve each and every numerical. So learn everything and be perfect in the topic so that any question is asked in the board exam or anywhere, you will be able to answer it. Before going to the main topic, that is heat capacity and specific heat capacity, we need to know the basics of temperature and heat. First we'll understand the basics of heat, then we'll go for temperature, then we'll go for the main topic. Listen. First, internal energy. What do you mean by internal energy? I'll give you one example. You take a molecule. Any molecule will consist of many atoms, correct? All these atoms will be randomly moving. Movement is nothing but kinetic energy. And some of the particles will not be moving. So it will possess potential energy. The sum of kinetic energy of the molecule and potential energy of the molecule is called as internal energy. I'll repeat it. See, definition and all you will get it from textbook. I want you to understand it in this video. So the sum of potential energy and kinetic energy of the molecule is called internal energy. Next, what do you mean by thermal energy? The total internal energy of all the molecules. We talked about only one molecule when it comes to internal energy, correct? The total internal energy of all the molecules in a substance is called thermal energy. See, whenever we talk about internal energy, we talk about few atoms are nothing but molecules. So whenever we talk about thermal energy, like this, how many molecules are there in the complete substance, okay, is called thermal energy. Now we'll talk about hot and cold bodies. See, these are very much important because these are completely basics. You need to know all these things. Hot and cold bodies. See, hot bodies will have high internal energy compared to the cold bodies. Hot bodies have more internal energy compared to the cold bodies. Listen, whenever a hot body is kept in contact with the cold body, a hot body is kept in contact with the cold body, the internal energy of the cold body increases, but at the same time internal energy of the hot body will decrease. That shows there is some energy is flowing from hot body to cold body. So whenever you keep hot body and cold body in contact, the internal energy of the cold body increases and hot body decreases. The internal energy of the hot body decreases. That shows energy flow from hot body to cold body. So heat is a form of energy which flows from hot body to cold body whenever they kept in contact. That is the definition of heat. Then we'll talk about units of heat. There are the SI unit is joules, okay. Common unit is calorie. So not SI unit. Calorie is not the SI unit, it is common unit. Instead of joules, we sometimes use calorie also. So 1 calorie. See, calorie can be written in short form of cal as a unit. Joule can be written as capital J. So 1 calorie is equal to 4.2 joules. So here actual answer is 4.186, but we round it off to 4.2 to make the calculation easier. In the exam you can take 4.2, you will get full marks. Next, 1 calorie. See, 1 calorie we have to define. How do you define 1 calorie? This is one important definition like heat. See, heat energy required. The heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So how do you define 1 calorie? The heat energy required, the amount of heat energy required to to raise the temperature of water, 1 gram of water. 1 gram of water is very much important. Okay, 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So here the important one thing is 1 calorie as, and one more name, that is nothing but 15 degree calorie. 15 degree calorie is nothing but 1 calorie. So in the exam, if they ask anything, okay, definitely they'll confuse you with these kind of words. Okay, in any words, if they ask, the definition remains same. So 1 calorie and 1 kilocalorie, how they are completely different. Simple, the definition remains same. Instead of that 1 gram of water, you should write 1 kg of water. That's it. So I'll repeat the definition of 1 kilocalorie. The heat energy required to raise the temperature of 1 kg of water from 14.5 degrees Celsius to 15.5 degrees Celsius. This is the definition of 1 kilocalorie. So if you know this much about heat, then I think you have learnt everything about the basics of heat. So whatever the question they ask about the heat, you will definitely able to answer. Now we'll learn everything about the temperature. Very simple concept, and if you know this much about temperature, I think you have learnt everything about temperature, that to basics of calorimetry. Listen, see, when the temperature rises, first you need to understand that before going to the definition. Listen, whenever an object receives an heat energy, they start vibrating, the molecules start vibrating vigorously, so that results in rise in temperature. Okay, now this is how the temperature rises in a molecule. So they'll start vibrating vigorously when they receive heat energy. Now we'll talk about temperature, definition of temperature. Okay, temperature is a parameter which tells the thermal state of a body. What do you mean by thermal state? Whether it is hot or cold, that is nothing but the thermal state. Temperature tells us whether the object is hot or cold, that is nothing but the thermal state, and it also determines the direction of flow of energy from one body to another body when they are kept in contact. The condition should be, they should be having two different temperatures. Now we'll talk about different units. See, SI unit is Kelvin, keep that in mind. SI unit of temperature is Kelvin. Commonly used is degree Celsius. So this is not SI unit. Not SI unit. The SI unit is Kelvin. So how these two are related? Listen, Kelvin is equal to 273 plus C. See, 273.15 is also fine, or 273, rounding off to 273 is also fine. You can use this one just to make the calculation easier. See, they are not going to ask you to convert from Kelvin to Celsius or Celsius to Kelvin. Okay, but you should know the relation between Kelvin and Celsius. Now we'll talk about absolute zero temperature. The zero of the Kelvin scale is the temperature at which where the molecular motion ceases. Ceases means stops. See, absolute zero temperature means that is nothing but the 0 Kelvin, the value of Kelvin is 0, okay, and it is the temperature at which the molecular motion ceases, the molecular motion stops. That is nothing but absolute zero temperature. Then minimum temperature possible. What is the minimum temperature possible? That is nothing but minus 273 degrees Celsius. Minus 273 degrees Celsius. It is not minus 273 Kelvin. It is minus 273 degrees Celsius. That is equal to 0 Kelvin. 0 Kelvin. So below 0 Kelvin it is not possible. Okay, the maximum, the last point for Kelvin is 0. The minimum value of Kelvin is 0. Negative values in Kelvin is not possible. Keep that in mind. Next, a rise in 1 degree Celsius. This is very much important because based on this one only we are going to solve many numericals and many theory questions, and you need to know the reason also. Listen, a rise in 1 degree Celsius is equal to rise in 1 Kelvin. How this is possible? See, Kelvin is equal to 273 plus degree Celsius, but I am telling rise in 1 degree Celsius equal to rise in 1 Kelvin. See, rise in 1 degree Celsius is different, Celsius is equal to Kelvin is different. Okay, this doesn't mean 1 degree Celsius is equal to 1 Kelvin. This is different and this is different. This tells us the equivalent value. This tells us how much rise in 1 degree Celsius will result in rise in 1 Kelvin. I'll give you one example, then you will understand. See, assume 1 degree Celsius is equal to 274 Kelvin, correct? 2 degree Celsius is equal to 275 Kelvin. 3 degree Celsius equal to 276 Kelvin. See, from here to here, okay, how much difference is there? 1 degree Celsius. From here to here, 1 Kelvin. From 2 degree to 3 degree, 1 degree is the difference. Here, 1 value is the difference. That means how much ever you rise, 1 degree Celsius is equal to 1 degree Kelvin. That's it. Now we will learn the factors affecting heat absorbed by a body. What are the factors affect how much heat energy is absorbed by a body? It is both, okay, both increase in temperature and decrease in temperature. For heating and cooling, the factors remain same. First factor, the mass. Okay, mass is directly proportional to heat absorbed by the body. Directly proportional to heat absorbed by a body. That means more the mass, it will absorb more heat energy. This is one of the factor. Next, rise in temperature. Rise in temperature, this is nothing but delta T. Delta T is nothing but rise in temperature. So how much rise in temperature? This is also directly proportional. Rise in temperature is directly proportional to heat absorbed by a body. See, in the exam you should not use symbols, you should write the full form. This one also you can write it like this, or you can use the sentence form. Mass is directly proportional to heat absorbed by a body. Rise in temperature is also directly proportional to heat absorbed by a body. Then our last factor, that is material. See, different material absorb different amount of heat. That depends upon specific heat capacity. Specific heat capacity. This one, don't worry about it for now. We are going to learn about it in the same chapter, okay, same part of this video. So what is the third factor? It depends upon specific heat capacity. So how can you write it in the sentence? When it comes to material, different materials absorb different amount of heat, so that depends upon specific heat capacity. Now we will learn the difference between heat energy and temperature. Whatever we are going to learn now, this we have already learned, but when it comes to differences, we need to understand how to write it in the exam. See, first you have to write it like this. Then first, this one difference should be always definition. See, if it is for 1 mark, don't go for definition as a difference. Go for SI unit. There you will get the answer easily. If they are asking more than 1 mark, most of the time they will not ask these kind of questions. Differences between any two quantities in physics will not be asked more than 1 mark. If they ask maximum, it may be for 2 marks. So learn two differences between them. See, first point will be definition. Next, heat depends upon mass, temperature and substance. What kind of substance it is? Heat depends upon all these factors, but temperature depends upon average kinetic energy of the molecule. Then here heat is measured by the principle of calorimetry. This is measured by the principle of calorimetry, and this one by thermometer. So write it in the form of sentence. That is, temperature is measured by thermometer. The SI unit of heat is joule. Here it is Kelvin. That's it. If you know these many differences, that is well and good for the board exam. Now we will jump into the main concept, that is nothing but thermal capacity. It has one more name, heat capacity. It is famous in heat capacity only. Most of the time we will use heat capacity only. Now how can we define it? Heat capacity of a body is the amount of heat energy required. Amount of heat energy required to raise the temperature of a body. To raise the temperature of a body by 1 degree Celsius. To increase 1 degree Celsius of temperature, how much of heat energy is required? That is nothing but heat capacity. So it is defined using this symbol. C dash is the symbol for heat capacity. If dash is not there, that represents different term that we are going to learn after this one. So heat capacity is denoted by C dash. So it is the amount of heat energy required. Heat energy, Q is the symbol for heat energy, keep that in mind. Q is the symbol for heat energy, and to raise the temperature by 1 degree Celsius. So here C dash is equal to heat capacity, Q is equal to heat energy, delta T is equal to rise in temperature. Now we'll talk about Q. See, Q means heat energy, correct? In exam or in any of the questions, they'll use in different way. Q will be used in different way. Heat energy observed, heat energy attained, heat energy required, all those things means Q only. So if they are talking about anything about heat energy, you are talking about Q. So if they are asking you to find heat energy required, attained or observed, you are going to find the value of Q. That's it. Next, if it is a physical quantity, then it should have some unit, right? So unit will be joules per Kelvin. Joules per Kelvin. See, the unit of Q, okay, is nothing but heat energy, that is joule. Rise in temperature, temperature unit will be Kelvin. So it has one more unit, that is nothing but joules per Celsius. So in the exam, most of the time they'll use this one only. If they use this one also, you should not get confused. These two are the units of thermal capacity or heat capacity. If you know this much about heat capacity, don't learn it, understand it. Okay, learning means you are just learning for the sake of exam. Understand it, so you can answer any give reason type of questions. That's it. Now we'll talk about very important topic, that is nothing but specific heat capacity. The definition of specific heat capacity goes exactly almost same like heat capacity. We are going to add one word. That's it. I'll define it. Listen. The specific heat capacity of a body is the amount of heat energy required to rise the temperature of unit mass. This unit mass is very much important. This word unit mass is not there in heat capacity. So this unit mass is very much important when it comes to specific heat capacity. To raise the temperature of unit mass by 1 degree Celsius. This is the definition of specific heat capacity. So whatever the heat capacity we are learning, that is for the entire mass of the substance. Whatever the specific heat capacity we are learning, this is for the unit mass. Unit mass may be 1 kg or 1 gram. So it depends upon the unit. Now the symbol for specific heat capacity is C. See, C dash is the symbol for heat capacity, just C is the symbol for specific heat capacity. Now we'll go for the formula. See, this was the formula for heat capacity, correct? This was the formula for heat capacity. Now we are adding one more word, unit mass, so we have to divide it by mass. So C is equal to Q by M delta T. This is the formula to find the value of specific heat capacity. If you can find it, it is a physical quantity. If it is a physical quantity, it has some unit, correct? Unit will be joules per kg per Kelvin. This is the SI unit. What is the SI unit of specific heat capacity? Joules per kg per Kelvin. This is the SI unit of specific heat capacity, and joules per gram per Kelvin. Everything remains same, but instead of kg we are going to use grams. This is the another unit or CGS unit of specific heat capacity. Now we have learned the definition, formula and unit. We need to understand the inner meaning of specific heat capacity. That is nothing but, I'll give you one example. See, specific heat capacity. Now onwards I'll use short form, but in the exam you should never use short form. You should always use expanded form. Specific heat capacity of copper, okay, Cu, copper is 0.4 joules per kg, sorry, it's not kg, joules per gram per Kelvin. So what you mean by this statement? So these kind of questions only they will ask in board exam. More than the definition, they just want to know how much you have understood about this concept. See, specific heat capacity of copper is 0.4 joules per gram per Kelvin. That means copper requires 0.4 joules of energy, heat energy, to rise the temperature of 1 gram of copper. 1 gram of copper to 1 degree Celsius. I'll repeat. Copper requires 0.4 joules of energy to raise the temperature of 1 gram of copper to 1 degree Celsius. So to increase 1 degree Celsius of 1 gram of copper, it requires 0.4 joules of energy. If they mention instead of gram, okay, if they mention instead of gram, if they mention kg, then you have to write, see, this will be 400 joules per kg per Kelvin. 400 joules per kg per Kelvin. That means it requires 400 joules of energy. Copper requires 400 joules of heat energy to raise the temperature of 1 kg of copper to 1 degree Celsius. That's it. So this is how the difference goes between joules per gram per Kelvin, joules per kg per Kelvin. If you know the inner meaning of specific heat capacity, that means you have understood the concept instead of by hearting. Next, we'll talk about the relation between specific heat capacity and heat capacity. See, heat capacity is equal to specific heat capacity into mass. This is the relation between, see, this is the symbol for heat capacity, and this is specific heat capacity into mass. See, if you these formulas are very useful in the numerical. So listen, heat capacity is equal to specific heat capacity into mass. This is the relation between, in the exam they may ask you the relation also. This is the relation between heat capacity and specific heat capacity. Now we will learn important things about specific heat capacity. Most of the give reason type of questions will be based on this concept only. If you know the definition of specific heat capacity and inner meaning also, it is good, but these are very useful to solve give reason kind of questions. Listen, first thing, very good conductors will have low specific heat capacity. Keep this in mind. Will have low specific heat capacity. Very good conductors or good conductors will have low specific heat capacity, and poor conductors will have high specific heat capacity. So first thing is you need to understand the difference between those two, good conductors and why they have low specific heat capacity. What do you mean by low specific heat capacity? What do you mean by high specific heat capacity? I'll explain through this example. Listen. SHC, specific heat capacity of copper, is 0.4 joules per gram per Kelvin, and the same thing, specific heat capacity of water is 4.2 joules per gram per Kelvin. Okay. Listen, compared to copper and water, which is very good conductor here, copper, so it has low specific heat capacity, and water is poor conductor compared to copper, so it has high specific heat capacity compared to that one. Listen, first thing you need to understand why there is a difference like this. Specific heat capacity tells us for how long an object can store heat energy. Specific heat capacity, the value of specific heat capacity tells us for how long the heat energy can be stored in an object. See, you take an example of copper and water also. Okay, assume you take a copper vessel, inside that you pour water, okay, and you try to boil it. Now for both copper and water the temperature rises, but the temperature of copper rises rapidly. This is the very important point. The temperature of copper rises rapidly. That means the copper attains the more temperature in less time. Once you take the water out of the copper vessel, the temperature of copper decreases rapidly. That means the increase in temperature or decrease in temperature happens rapidly in copper compared to water. So, but when it comes to water, the temperature rises slowly, and if you turn off the vessel, this one gas stove also, the temperature of the water decreases slowly. It will not happen rapidly. This is the difference between copper and water. So, if the temperature of any element or substance, okay, increases rapidly or decreases rapidly, that has low specific heat capacity. If the temperature of an object increases gradually and decreases gradually without rapid rise or decrease in temperature, that will have high specific heat capacity. So this is the difference between copper and water. Not only between copper and water, any good conductor and poor conductor. Water is also a conductor of heat. We are not talking about conductor means it is not about conductor of electricity. That is completely different. This here we are talking about conduction of heat. Okay, conductor of heat. So copper is a very good conductor. Water is a poor conductor compared to copper. So very good conductors will have low specific heat capacity. So based on these things they are going to ask you give reason. Once you understand all these concepts, we are going to solve each and every theory question correct from the textbook. That video and numerical videos, each and every numerical we are going to solve. All these two videos will be available in the description box. So once you understand the concept of calorimetry, immediately go for theory questions. There you will understand what are the reasons, how to write the answers in the board exam. So then only you will understand around 40 to 50%. Remaining percentage will be for numericals and application oriented questions. So once you solve the concept, then go for the theory solution. After that numericals, then you will understand the complete things about calorimetry. Not only about this chapter, every chapter you should learn in this way only. If you do like this, you don't have to touch the textbook only. You will get maximum marks. After that, how to deal with the application questions after solving all the videos of all the chapter, I'm going to teach you how the answers for board exam papers. Okay, then you will understand how to deal with the application oriented questions. Then you will completely learn everything. Now, high specific heat capacity in a liquid. Which liquid has high specific heat capacity? That is nothing but water. Okay, water, when it comes to liquids, water has high specific heat capacity. But when it comes to overall substances, any substance which has high specific heat capacity, that is nothing but hydrogen. Okay, overall, if they are asking which substance or which element has a high specific heat capacity, you should go for hydrogen. If they are asking specifically about liquid, which liquid has high specific heat capacity, you should go for water. So if you know these many things about specific heat capacity, then I think definition is done, formula is done, units are done, inner meanings are done. Okay, which will have high specific heat capacity, which will have low specific heat capacity, and why it has low specific heat capacity and why it has high specific heat capacity, that you should know. If it has low specific heat capacity, that means the temperature rises rapidly. Okay, if it has high temperature, high specific heat capacity, that means the temperature will not rise rapidly, it will rise gradually. That's it. Now we'll talk about calorimeter. See, calorimeter is a cylindrical vessel which we use to measure how much amount of heat is gained or heat is lost by a body when it is mixed with another body. I'll give you one example. First in this one, in calorimeter, we'll take hot water. Okay, hot water, then we'll pour some cold water. When we mix two different substances, how much amount of heat energy is gained by cold water or how much amount of heat energy is lost by the hot water, that is what we are going to measure using calorimeter. Now these are the four give reason you can expect in the exam. See, calorimeter actually it is not there in the syllabus, but for any this one competitive exams, these are very much helpful, and only these kind of questions they will ask in the exam. Listen, why copper? They'll use thin copper sheet. They'll use thin sheet of copper for calorimeter. Why we have to use copper? Because one thing is it's a good conductor, and it has low specific heat capacity. If it is a good conductor, it has low specific heat capacity. These are the two reasons why we have to select copper. Then why it is polished? See, the inner and outer surface of the copper is polished. Why it has to be polished? To avoid the loss of heat, in the form of radiation. To avoid the loss of heat in the form of radiation, we polish both inner and outer surface of the copper or calorimeter. Next, why wooden lid? On the surface, on the this one copper cylindrical vessel, there will be a wooden lid. So why we have to keep that wooden lid? Why? Because to avoid the loss of heat, in the form of conduction. To avoid the loss of heat in the form of radiation, we will polish the inner and outer surface of the copper or calorimetry. We'll close it. Okay, we'll close it with wooden lid to avoid the loss of heat energy in the form of conduction. Next, why wool? See, between the wooden block and the calorimeter and the copper vessel, there will be wool. Okay, wool will be filled. This will provide insulation. What do you mean by insulation? It will not conduct heat energy. That's it. So these are the possible give reason questions based on the calorimeter, definition of calorimeter and give reasons. That is enough. Working is not there, and the complete concept is see, if you know it, it is well and good. So whatever their questions they may ask, you can easily answer. Now we'll talk about very important thing about this chapter, that is nothing but principle of method of mixture. Why this is important? Because 4 mark or 3 mark numericals will be based on this one only. So principle of method of mixture, very simple. See, first thing is you need to understand the concept, then substituting the values and getting the answer. That's it. But the calculation will be little huge compared to other chapters. That's it. Listen, principle of method of mixture. So this principle of method of mixture has one more name, that is nothing but principle of calorimetry. See, this is the another name for principle of method of mixture. Now we will understand what do you mean by principle of method of mixture. They'll ask these kind of questions only. So define principle of method of mixture or explain principle of method of mixture. Whatever the question they ask in board exam about this one or this one. See, this is the another name for principle of method of mixture. This can also they may ask. What is another name for principle of method of mixture? You have to be ready with everything. This means heat energy lost by a hot body is equal to this is equal to heat energy gained by a cold body. So this is the meaning of the principle of method of mixture. While solving the numericals, they'll ask us to write the assumption. What is the assumption you are going to assume in this numerical? This is the assumption. Whatever the heat energy lost by a hot body is equal to heat energy gained by a cold body. That means what is the assumption we are making? Though there is no loss of energy, so the energy whatever that is converting from a hot body to cold body, that is not wasting, that is not getting wasted into any form of energy. So this topic is based on which law? Okay, this concept is based on law of conservation of energy. Law of conservation of energy. That means whenever you convert one form of energy to another form, whatever the energy is there, okay, initial energy, that will be the final energy. So this is called as law of conservation of energy. Now we'll talk about the mathematical form. So the derivation is not there in the exam, don't worry. Only the mathematical form, that is nothing but the formula we are going to learn, that is useful for the numerical. Listen, m1 c1 t1 minus t is equal to m2 c2 t minus t1. See, here it is t1 minus t, here it is it is t2. Okay, now if you can understand the words, okay, the meaning of these symbols, aramse you can get the numerical. Listen, m. See, whenever we talk about principle of method of mixture, what do you mean by that? One object is mixed with other object. So how many objects are there? How many substances are there? Two substances. So this side will talk about heat energy lost by a hot body. So always on the left side, try to write the object as maximum temperature. Left side, what you are going to write? The object which has maximum temperature, that you are going to write it. Assume a copper of 80 degree temperature. 80 degree temperature is mixed with a water at 10 degree temperature. So which has high temperature here? The copper. So copper, everything related to copper should be on the LHS. So which has the lowest temperature? That should you write it on the RHS. Okay, now this is completely related to the hot object. This is completely related to the cold object. Listen, mass of that object and specific heat capacity. See, it represents specific heat capacity of that object, temperature of that object, and we'll talk about this one later. Now again, mass of the second object, that is nothing but if you take copper here and water here, this is the mass of the water, specific heat capacity of the water. T2 means temperature, initial temperature of water. T1 means initial temperature of copper. T represents final temperature. When you mix this, okay, when you mix the copper in the water, the temperature decreases, the temperature of the copper decreases, right? So what is the final temperature? So again, when you mix the copper with the water, the temperature rises. What is the final temperature? So T represents final temperature here. M1, mass of the hot object, specific heat capacity of the hot object, initial temperature of the hot object. This is the initial temperature of the cold object, and T represents the final temperature of this mixture. That's it. So, and if you know all these things, you can solve any numerical. We are going to learn each and every numerical from the textbook. So if you learn that many numericals, I think you are ready for any numerical they are asking board exam. Now assume we are going to add one more thing here, the same formula I'm going to add one more thing in different condition. C2, this is T minus T2, then plus MC T minus T2. So what is this addition? This extra addition you have to take whenever this is done in calorimeter. If this concept is done, mixture of two objects is done, see they'll mention, most of the time they will not mention the calorimeter, then you have to go with this formula only. If they mention it is done through calorimeter, you are going to add one more thing, that is nothing but mass of the calorimeter, specific heat capacity of the copper or calorimeter, the same thing, whatever the temperature here, that's it. Okay, so this is for mixing two objects. Okay, they will not mention which vessel or where it is mixing. Okay, if it is not specifying, you should go for this one. If it is done through calorimeter, they'll mention, okay, they'll give you the mass of the calorimeter, specific heat capacity of the calorimeter, all those things. If it is mentioned, you have to go with this formula. The same thing, addition of calorimeter data, that's it. Now our final concept, natural phenomenon of specific heat capacity of water, natural phenomenon and consequences of specific heat capacity of water, anything is fine. See, this is the specific heat capacity of water in SI unit and in CGS unit. Just to note it, that's it. I want you to keep on saying it and storing it in your brain. Listen, in that, first we'll talk about this concept. The climate near the seashore is moderate. Why the climate near the seashore is always moderate, not even cold and not even hot, all those things? Why it is always moderate? The answer is very simple. See, there are many, these kind of questions will be asked in a board exam as a give reason. Whatever the last concept we are going to learn, everything is based on a give reason question. Maximum mark will be given for these kind of give reason is 1 mark. So make sure your answer is very precise. So this is a complete concept. Okay, using this they'll ask you one simple concept to write the answer for 1 mark question. So understand it, whatever the question they ask, you can write it everything to get the marks. Listen, the climate near the seashore is always moderate. Why it is not even cold or not even hot always? It is completely moderate. Why? Because see, first thing you need to know is specific heat capacity of water is 5 times the specific heat capacity of sand. This you should know. Specific heat capacity of water, that value is 5 times the specific heat capacity of sand. That means whatever the, say, assume to reach certain temperature, the sand requires some energy, correct? Some energy. To reach the same temperature, the water requires 5 times the heat energy than the sand. That means, see, water requires 5 times more energy, 5 times more heat energy to reach the same temperature of the sand. That means, so it requires a lot of energy, 5 times more energy than that one. So what happens? So this is the main reason, this is the main concept. So what happens during the night? During the night, it is a land breeze. What do you mean by land breeze? The air flows from a land to coastal area, land to seawater, Say this concept is completely based between water and sand, during night. See, first thing is you need to know specific heat capacity of water is 5 times the specific heat capacity of sand. That means it requires 5 times the heat energy of sand to reach the same temperature. So during the night, what happens? Land breezes. What do you mean by land breeze? The air flows from land to seawater, So this will be cold air. So this is not some air, this is cold air. So the cold air moves from land to sea. So what happens when the cold air moves from land to sea? The seawater will keep on, the temperature of the seawater will keep on reducing during the complete night, and during the day, during the daytime, okay, this is called as sea breeze. So the cold air will move from sea to land. See, then here the difference between these temperature, the difference in these breezes makes the climate near the seashore moderate. This is the concept. See, this one you should know. And during the night time, land breeze means cold air moves from land to sea. So that sea water will take the temperature, cold air temperature, and the temperature reduces in the sea water gradually throughout the night. During the day, now the sea water is cold. That cold water will move from sea to land. These differences in temperature, these differences in breezes will maintain the climate near the seashore as moderate. So this is the reason. These kind of questions will be asked in the board exam. So whatever the give reason questions we are going to solve during the theory question, we are going to skip it. Why? Because we are learning it here, right? We are learning in depth. So we are not going to answer give reason type of questions only based on natural phenomenon on specific heat capacity of water. The next phenomenon, hot water bottles are used for fermentation. First thing is you need to understand the meaning of fermentation. Okay, fermentation is nothing but pain relieving process. Assume you have a pain here, we will keep hot water here, right? This process is called fermentation. So hot water, why we have to use hot water bottles only? Why? Because see, for all these kind of questions, whatever related to water, first reason you are going to write it has high specific heat capacity. First thing you write it. For that only they are going to give full marks. See, because water has high specific heat capacity. Whatever the question they ask, okay, if you get to know this is based on calorimetry and water, first write water has high specific heat capacity. For this one only they will give full marks. And see, what do you mean by this statement? You have to mention that also. Listen, first you write this one. Water has high specific heat capacity. What do you mean by high specific heat capacity? That means the water can hold the temperature for a longer time. The water can hold to increase the temperature, water will take huge longer time to get rid of the temperature. To decrease the temperature also, water will requires longer time. So when you keep hot water here to cool down, it will take large amount of time. So it provides the required heat energy, and the temperature of water will not reduce immediately. This is the reason why we are using hot water bottles as fermentation. Our next phenomenon, water is used as an effective coolant. This is an application word. Okay, this is an application word, fermentation. If you know the meaning, you can answer it. What do you mean by effective coolant? That means, assume you take an example of a machine. Okay, in the machine, whenever there is a moving part or anything, it will acquire high temperature. We need to remove that high temperature from that machine to safeguard it, correct? So what we'll do is, we'll pour some water. Okay, we'll pour some water using a tube. Inside the tube, the water will flow. While flowing, the temperature of that machine will be taken by the water. That is nothing but the meaning of this question. So whatever the question they ask, first thing you're going to write is water has high specific heat capacity. Water has high specific heat capacity. So whenever the water flows through the tube, it will not attain the high temperature rapidly. It will not get that high temperature from the machine rapidly, and it removes the temperature from the machine part. That's it. Now, in cold countries, water is used as reservoir to avoid wine and juice bottles to freeze. See, in cold countries, the temperature will be very low. So, what they'll do is they'll immerse the wine bottle and juice bottles in water. So, why they are doing like that? Just to avoid them to get freeze. They don't want the wine or juice bottle to freeze. So what they'll do is they'll immerse it into water. Why? Because water has, again, first thing you are going to write is water has high specific heat capacity. And see, to increase the temperature, while increasing the temperature or decreasing the temperature, water requires a lot of heat energy to cool down. During the cold time, it requires lot of heat energy to go to the freezing point. Correct. So, but wine bottle and juice bottle will go immediately because their SHC, so specific heat capacity, is very low. That means they'll freeze down faster compared to water. So, water will require large amount of heat to freeze down. So, whenever there is a cold temperature, water will require large amount of heat to freeze. So what they'll do is, whatever the answer you're going to write, that should be water has high specific heat capacity and it requires large amount of heat, okay, a lot amount of heat energy to go to the freezing level, and it requires a larger time to reach the temperature. This is the answer you're going to write. And next, farmers fill their fields with water during the winter. During the winter season, the farmers will fill the fields with water. Why? Because see, if you don't fill the fields with water, what happens? First we need to understand. If you don't fill it during the winter time, the temperature will be very low, and the capillaries in the plants will be filled with water. Okay, filled with water, and due to the cold temperature, they'll freeze and the veins will be burst. The veins of the plants will be burst, and that will destroy the crop. So what they'll do is they'll fill the fields with water. Why? Because water has high specific heat capacity, and in the winter time, in the cold temperature time, water requires a large amount of heat to go to the low temperature, so it will protect the crop. Our last phenomenon, see, all plants and animals have high water content in their bodies. See, it seems like biology question, but it is physics related question. Listen, you can answer it through biology also, but in physics we are going to write the answer in a different way. Listen, all plants and animals have high water content. 80 to 90%, 80% to 90% of the bodies of plants and animals, including us, is made up of water. So why it has to be made up of 80 to 90% of water? Why? Because to maintain the same temperature, throughout all the seasons, in all the seasons, winter and summer, rainy season, in all the seasons, we have to maintain the same temperature. The body has to maintain the same temperature. That is why it is made up of 80 to 90% of water content. That's it. Some examples for low and high heat capacity. Heat capacity symbol is C dash. See, one thing you should know is how heat capacity is related to specific heat capacity. Heat capacity is equal to specific heat capacity into mass. So if the heat capacity increases, specific heat capacity also increases. This you should know. So whenever you get a give reason questions like this, you can specify heat capacity or specific heat capacity. For both the things you are going to get full marks. Okay, listen. So the base of the, see, whenever something is related, like why it is made thick, why it is made thin, all those things, it is related to specific heat capacity or heat capacity. Keep that in mind. Now the base of the cooking pan. So the base of the cooking pan, why it is made thicker? So if it is made thicker, okay, if it is thicker, heat capacity will be high. If it is thicker, heat capacity will be high, so that it can retain the high temperature of the food after cooking. So after cooking also it can retain the high temperature for a longer time, so that is why it is made thicker. Listen, why the base of the electric press? What do you mean by electric press? It is nothing but iron box. Okay, electric press is made thicker. The base of the electric press is made thicker because thicker means to increase the, it is made thicker to increase the heat capacity. Okay, to increase the heat capacity, so that, okay, the temperature will be very high. The temperature will be very high. The temperature will be high, even the power goes off. If the power of the house, the electricity goes off, the temperature will be very high. That is why the electric press, the base of the electric press is made thicker. Then thin sheet of copper. See here, in both the cases we use thick. Thick means high heat capacity. Thin means low heat capacity or low specific heat capacity. So it should have low specific heat capacity, so that it will attain the temperature by absorbing less amount of heat. See, it will take, why do we use thin copper sheet in calorimeter? This is used to measure the heat gain or lost by the substance, right? So it should not absorb most of the energy, most of the heat energy from the material. If it is absorbing most of the energy, then the measurement will go wrong. That is why it is made made as thin sheet of copper in calorimeter, so that its specific heat capacity will become low. If it is low, the heat energy absorbed by the material will be very less, so the measurement will be almost accurate. So these are the reasons. Listen, whenever they talk about thickness or thinness, it is mainly based on specific heat capacity. So first thing is, if it is thicker, you should write it has high specific heat capacity or heat capacity. If it is thinner, you should mention it has low specific heat capacity. This is the first condition, whether you are going to get marks or not. Then it is based on the reason what you are going to give. So if you know this much, that means we have learnt everything. The complete concept of calorimetry part here we have learnt. After this, we are going to solve each and every theory question. After that, each and every numerical. Those two videos will be also available in the description box. Watch it, learn it properly. Once you watch the concept video, don't see the theory question or numerical question after few days or after few weeks. Then you will completely forget all these things. So immediately after learning this concept video, go for theory question. You will understand. All these knowledge will be in your brain for a longer period of time. That means you have high specific heat capacity. Your brain will have high specific heat capacity. So it will take longer time, but it will store it for a longer time. Thank you.